Welcome everyone to physics class. I am Adetunji Emmanuel, and in this video, let's learn about motion. So, introduction to motion. At the end of this class, our aims and our objectives are number one, to introduce us to what motion is all about. Number two, to be able to understand the different types of motion and the concept of force, what force is all about. Okay, so the first one is introduction to motion. What exactly is motion? Now, motion involves a change of position of a body with time. Okay, it also involves how things move and what makes them to move. And motion exists in different forms. It can occur in solid, in liquid, and in gases, the three states of matter. And when we're describing motion, there are two key points that we all must know. The first one is kinematics, and the second one is dynamics. Okay, so the first one is kinematics. What exactly is kinematics? Kinematics is the description of how objects move without regard to forces causing their motion. So when you are describing how objects move without considering the forces causing their motion, they are dealing with kinematics. Okay, and dynamics deals with why objects move as they do. So you are considering what is making objects move as they do. Okay, good. The next one is types of motion. What exactly are the types of motion? So we have different types of motion. As you can see right here, you have periodic motion, we have rectilinear motion, we have curvilinear motion, oscillatory motion, circulatory motion, and translatory motion. But let us look at it in full details right here. The first one is random motion. Okay, and random motion is a type of motion in which a body moves in a non-linear manner and changes direction continuously, aka the body moves zigzagly. Now look at this picture right here. As you can see, these molecules are moving randomly right about, and as you can see also, this particular body or object is moving in a non-uniform manner, right, moving anyhow exactly. So examples of random motion are: number one, the molecular movement in gases. Okay, and number two, dashing of objects in air, e.g. insect. Do you know the way insect move? Insect does not move in a straight line. It goes it goes anyhow. It goes in a non-linear manner. Okay, and second type of motion is the rotational motion, and this is the movement of a body in a rotational manner about its axis. So when a body or an object rotates roundabout, right, about its axis, that is called a stemmed rotational motion. Examples are the rotation of electric fan blades, as you can see right here. Now these fan blades are rotating around this axis, right, what is holding it. So the axis right there, so the fan blades are rotating round about the axis. Okay, we also have the rotation of the head about its axis. So the head right here is rotating right about its axis. We also have the movement of car wheels and the rotation of ferry wheels. Okay, now this is a ferry wheel right here. So as you can see, the ferry wheels are rotating about its axis. So it's a type of rotational motion. So when you're asked to describe rotational motion, it's simply a movement of a body in a rotational manner about its axis. Okay, good. The next one is translational rectilinear motion. Now this type of motion occurs when an object moves in a fixed direction. So if you see an object, or you notice an object or a body moving in a fixed direction, then that particular object is undergoing translational rectilinear motion. Examples are the movement of a car from a point to another. Now as you can see, this car is moving from one point to another, so it's going in a fixed direction. We also have human movement. So in this picture right here, as you can see, this human being right here is moving in a fixed direction. So it's a type of an example of translational rectilinear motion. Now the next one is oscillatory motion. Oscillatory motion. Now what exactly is oscillatory motion? This is a to and fro movement about a fixed point. Now it arises due to slight displacement of an object from the initial position to a new position and then backward. Examples are: we have simple pendulum, we have riding on a swing, we have vibration of a plucked guitar. Now, as you can see, this person right here is swinging to and fro, right? It's a type of what? Oscillatory motion. Now a simple pendulum, right, goes right and left, so it goes to and fro, right? Why? Because there was a slight displacement of the object from its initial position to a new position and then backward. So this type of motion is called a stemmed oscillatory motion. We also have, if you are playing a string, like if you are playing a guitar, now if you are plucking the guitar, say that the vibration of the guitar string also undergoes oscillatory motion. So these are the examples of oscillatory motion. Okay, The next type of motion is curvilinear motion. Curvilinear motion. Now, what exactly is curvilinear motion? Now, this is the type of motion of an object that moves in a curved path. So, if you see an object moving in a curved path, such an object is undergoing curvilinear motion. Now, the direction of the object velocity is constantly changing, and the path it takes is a curved line. Examples are, now if you throw a stone into the air at an angle, now let's say you catapult a stone. Now you just look at how the stone leaves the catapult after after shooting it, so that the particular stone moves in a parabolic path. It follows a curved path. Now that stone has undergone curvilinear motion. Also have a snake moving. Now you know how a snake move. A snake move like in a form of an S shape. Now that S shape is following a kind of curved path, right? So a snake also undergoes curvilinear motion. Also have roller coaster rolling, as you can see right here. So we have this particular picture of these small kids, right, moving down like they are in a roller coaster ride. So they are moving down, they are following a curved path as they go. Okay, so the next one is relative motion. What exactly is relative motion? Now, this is the movement of an object in relation to another body. The examples are pulling a string tied to a block of wood. Now, if you are pulling a string that is tied to a block of wood, as you know, is a type of relative motion. We also have the direction of a passenger with respect to a fixed point. I don't know whether most of you have ever noticed this scenario before. That if you sit in a bus, right, or you sit in a car and you look at, let's say, a pole outside the car, as the car is moving forward, the pole is moving backward. Isn't that so? Now, the pole normally is not moving at all, but because the car is moving forward, the pole will also be moving backward. Now, say that the movement of the body of the pole with respect to you as a passenger in the car is termed relative motion. You also have the bending a ruler on a beam. So in this picture right here, we can say that this particular person, right, is in a vehicle, is looking outside the window to a fixed point. Let's say he's looking at this house. Now, as the car or the vehicle is moving forward, the house is going backward. So the car is going forward while the house is going backward. Passenger is undergoing movement, right, relative to the house outside the window, which is also going backward. So it's a type of relative motion. Okay, good. The next one is force. What is a force? Now, force is an influence that can change an object's position, speed, or state of motion. It can also be defined as a push or pull that acts on an object, and also it is a vector quantity. Now, what do I mean by vector quantity? Now, a vector quantity is any quantity that has magnitude and direction. Okay, it has size and also has what direction, either north, east, south, west. So it has direction and also has magnitude. And force is denoted by capital F and is measured in Newton, capital N, as a unit, or kilogram meter per second square. So a force is an influence that can change an object's position, speed, or state of motion. Okay, and one thing that we must notice is that this is a vector quantity denoted by F and measured in what? Newton, capital N, or kilogram meter per second square. Okay, good. What are the types of force? We have two types of force. We have the contact forces and have the non-contact or the field forces. So now these are the example of contact forces. As you can see, we have this particular man right here pushing the trolley. Now his hand is in contact with the trolley, so he's applying force, but it's a contact towards force. We also have a spring force. We also have the drag force when an aeroplane is moving in the air, or let's say an airplane is moving in the air. The drag force by the air resistance, right, is in contact with the plane, so it's called a drag force. So a frictional force. Now frictional force is the opposing force that opposes motion. So have a normal force, and these are type of contact forces. But for the non-contact forces, in which there is no contact in between the two objects, but force still apply. Okay, so we have the magnetic force, we have the electric force, we have the gravitational force. But let us look into this in details. Okay. For the first one, which is contact forces. Now, these are forces that occur when objects are in direct physical contact with each other. Examples are friction, opposing force, tension, normal force, and applied force. Now, as you can see in this particular picture right here, this particular guy is pushing this block, right? Is applying direct physical contact to the block in order for it to to move this particular block, or pull also. Now this particular movement, pull, is applying physical contact, so it's termed a contact force. Now we also have the friction force. Now friction force is the force that opposes motion. As you tend to push an object or pull an object, friction is that force that will oppose the motion. It's a type of contact force. Okay, we also have the field force, the second type of force, or the non-contact force. Now these forces act on objects without without requiring physical contact. Examples are gravitational force, force of gravity, electromagnetic force, and the nuclear force. Now, if you place unlike poles plus and minus, they will attract electrical force. But if you place like poles plus plus minus minus, they will repel each other. Now, without even without contacting, like without direct contact with each other, there will be a repelling force if you place like poles together. But there will be an attractive force when you place opposite poles together. Now, same thing also in magnetic force. Now, have you ever tried to use magnet to drag a nail before? In fact, even though you keep a small distance between the nail and the magnet, by the time the nail, right, is placed at a particular distance to the magnet, directly it does spontaneously drag the nail to itself. So it's the type of a non-contact force. It does not require any contact before the force takes place. Okay, good. So we've come to an end of today's class. I hope you've learned one or two. Thanks for listening.